Okay.
Looks like Brooklyn's got...
Brooklyn, yeah, set in. Do you have to be good at math to be a good programmer?
Yes.
Yeah. Basically, the answer to this one is that if you are a good programmer, you're already good at math, because programming and math are both solving complex problems with the manipulation of abstract symbols.
Maybe I'll put if you're good at one, you are probably good at the other, or something. I'm trying to simplify and shrink it down a little bit.
Yeah, I say specifically that if you're good at programming, you already are good at math, and that's because I think of programming as an applied mathematics, whereas math is a broader subject. So if you're good at math, you might not be a good programmer. But
I see. Yeah, I see what you're saying. It goes one way, not necessarily the other way.
Something like any math using symbols will only help you succeed better at programming, or something that's like encouraging.
Yeah.
And inclusive.
You might be more. You're better at math than you think you are.
Yeah. So if you're programming, you're probably better at math than you really think you are. There you go. Nice job.
Yeah. With this one, I found that directed acyclic graphs are something that I keep returning to again and again. And there's an algorithm to do with directed acyclic graphs to find a topological order within a partial order. So that's something that I found that even when I didn't expect to, I would always find myself writing that algorithm. Like a fully ordered set is like the numbers. You can tell, given any two numbers, this one came before that one. But with a partially ordered set, sometimes you can't tell one thing came before the other, but sometimes you can. So one good example is subsets. You can tell that this small set is a subset of this bigger set because everything that's in the small set is also in the bigger set. But these two sets might have some things in common, but other things are different. Right. So you can't say that one is a subset of the other.
Right.
So sets are
like a Venn diagram.
Yeah. Okay. Yeah. So with the Venn diagram, sometimes a bubble is completely inside of another one. Sometimes they overlap. So those bubbles are partially ordered.
Okay.
A topological order finds a way to put them into a full order, and there are multiple ways that you can put them in full order and still be correct.
This is what I wrote down. Finding a topological order of a partially ordered set, that's one that I always find myself returning to. So you mentioned that too. Does that work?
How many more characters do you have left?
16.
Yeah, just go with that.
That works and you feel good about that? Okay.
Yeah.
Okay.
But I remember there was this one professor that I guess I had gotten this reputation of always engaging and sometimes even finding, do you need if you missed a negative sign there, that kind of thing. And so there was this one time when he's up there working through a problem and somebody behind me just makes a remark that was just off, just really in left field. And so I guess I had this look on my face like, what? That doesn't make any sense. Because he turned around at that exact moment, looked at me, then looked back at the board and said, something wrong? I said, no, you're fine. This guy's an idiot. So yeah, can I prove that a program will never throw an exception? You can prove that a program will never throw a null reference exception. But for other kinds of exceptions, it's not always possible.
Is that why you do so much testing?
Yes.
Okay.
Yeah.
I feel awesome just being involved. I don't know what's going on, but I'm like, yeah. Okay, you can prove it for a null reference exception, but for others, it's not always possible. What for other
kinds of exceptions?
Other kinds of exceptions. Maybe I'll try it. I'll do that.
So I grew up with Carl Sagan and Cosmos, Nova, and just the way that he made cosmology and physics accessible. I really admired that. And so he's one of my idols when I'm trying to teach people software and teach people mathematics. Is that I try to evoke Carl Sagan. Well, the way that we teach math is very compartmentalized.
Yeah.
We teach algebra and we teach calculus and we teach trigonometry, but it's all the same form of logical reasoning. And so I think the fact that we compartmentalize it is doing us a disservice.
Yeah, I can see that.
Okay, so all right, CRUD Vista software. How can math help me? If you count the number of degrees of freedom in a business problem, the solution should have that same number. That's degrees of freedom is the number of things that can change.
Will someone that writes CRUD business software, they'll understand that phrase, degrees of freedom, or no?
No, they probably wouldn't. So if we say, if you count the number of things that can change in a CRUD application, or the number of things that can vary independently.
Does he know that he tweeted it twice?
Well, this might be a great example of a mistake in Twitter. One of the things that I talk about is a conference talk I call "Don't Click Submit Twice."
Yeah.
And it's building applications where you can't make a mistake like that.
Yeah.
And the mathematical term for that is endpoints.
Cool. So I think maybe we kind of wrap it up. Do you have any, I don't know, just some kind of little sign-off thing you might want to throw out there?
It's like, math is not the subject you learn in school. It's the language of reasoning.
Looks like it belongs on a t-shirt.
Yeah.
I like that.